Today we are talking about resultant vectors, and so yesterday we talked about adding vectors together, and so similar ideas where we're drawing something end to end and looking for this resultant vector once we've added two vectors together. So it goes end to end, and so some things that we're going to talk about today are like, okay, a plane is traveling and the wind is also traveling, and so we're looking at how those two things are interacting together. And so just some reminders for us. Remember that magnitude is Pythagorean theorem when you've been given x and y. Direction is inverse tangent. Make sure that you add the appropriate amount depending on which quadrant you're in. And then if you have been given magnitude and direction, you are multiplying the magnitude times cosine and the magnitude times sine of the angle measure, the direction that it's traveling. And some other things that are going to happen today are you may be given the direction in terms of north, south, east, west. And so we're just orienting ourselves north, south, west, east, and using the angle measures that we've been given before. So north, south, east, west, 0, 90, 180, 270, 360. And so the northeast would be 45, northwest would be 135, southwest would be 225, and southeast would be 315. And so using that unit circle is helpful as we're doing this today. So you may want to have that out with you as you're thinking through this. First things first, a Boeing 757, which is a plane, it's just a type of plane, is set to travel 475 miles per hour in the northeast direction. And so as we're reading this, hopefully you're seeing that the speed at which something is traveling is talking about our magnitude. And in the northeast direction, hopefully we can see that that's going to be our angle measure. And so if we go back, north, east, halfway in between north and east would be 45 degrees. And so what this really means is 45 degrees. So we have plane information, but then we also have wind information. But the wind is also blowing 25 miles per hour, so that's going to be the wind's magnitude and in the southward direction. So the wind is also blowing 25 miles per hour southward, and then we're going to draw a picture. Let's go back. Maybe you can visualize this, but just so that we can see, south is going to be 270 degrees. And so our picture here, I'm flying much faster than this one. And so our magnitude, remember, is the length of our arrow. And so if this is 475, the arrow for your plane needs to be much longer than the arrow for your wind. So our plane, I'm going to make red, and then our wind is going to be much shorter, and it's going in the southward direction. So I'm putting them end to end, plane first, then the wind, and then my resultant vector, which we will talk more about tomorrow, is going to be this one here. So today we're just focusing on plane information and wind information. So first things first, let's do the plane. We've been given magnitude and direction, and so my magnitude is 475 times cosine of my direction, which we said was 45 degrees, and 475 times sine of 45 degrees. And what we get when we type both of those separately into the calculator, we get 335.9 and 335.9. And so what I want you to think about is, like, does this make sense for this situation? And hopefully you say yes, because we used a 45-degree angle. And what we know about 45, 45, 90 triangles is that our two sides are the same. So if you're thinking about the 45-degree triangle on your unit circle, it's square root of 2 over 2 times, or square root of 2 over 2 and square root of 2 over 2. So the x value and the y value are the same. And so hopefully that makes sense for you, that this is the plane's information and that its x value and its y value are equal. And then we have the wind information. And the wind is blowing 25 miles per hour, cosine of 270. And 25 sine of 270. And when we multiply this out, maybe if you remember, cosine of 270 is what is the x value at 270? And that should be 0. And so 0 times 25 gives us a value of 0. You can also plug that in the calculator. And then we get a value of -1 for sine of 270 when we solved that weeks ago. So 25 times -1, it would be -25, which lines up with what's happening here. I'm going straight down. I didn't go left, I didn't go right, so my value is 0, and then I went down 25 units straight down at an angle measure of 270. And so hopefully those two values make sense for you, the plane's vector, and then the wind's vector. The second problem that we have today is a helicopter is taking our class on a tour over Houston. How nice for us. The route we are taking is 8 miles west and 10 miles north. And so in this one, hopefully as you're reading, you're thinking through, like, if I am going west 8 miles and I am going north 10 miles, hopefully you see that what we have been given here is really the x value and the y value. And so what distance are we traveling if we flew directly to the end point, and which direction are we going? And so hopefully you can see here that, like, we have created a right triangle, and what we're really being asked here is what is the distance, aka what's the magnitude, and then what is the direction. So we're looking for magnitude and direction. We've been given x and y, and so then that means that we're going to be doing Pythagorean theorem to find our hypotenuse and then figure out what our angle measure is going to be as we go that direction. And so here we have our magnitude is equal to the square root of 8 squared, which would actually be -8, plus 10, it's going north, and we would have the square root of 164, which is approximately 12.8, and that answer makes sense because that is the longer side between -8 and 10. And so this would be 12.8. And then our direction would be inverse tangent of our y value, +10 over -8, since we're going to the left. And that would give me -51.3. And because we're in quadrant 2, we need to add 180. And that's going to give me a final direction of 128.7 actually, 128.7 degrees. So our magnitude would be 12.8 and our direction would be 128.7. So nothing today is really new. What you are trying to think through is, like, what is the question actually asking us? Distance, direction, magnitude, direction, or is it like the other one where you've been given magnitude and direction and you're trying to find the x and y components? So be careful as you're reading the questions today. The questions are really going to help you figure out, what am I actually solving for? What have I been given? But it's either going to be magnitude and direction and I'm looking for x and y, or I've been given x and y and I need to look for magnitude and direction.